The war for computational power has begun, and the battlefields have names: NVIDIA and blockchain. In the digital world, power isn't measured in weapons but in calculations per second. And here, the numbers speak louder than any speech. To give you an idea, the fastest NVIDIA supercomputer, the DGX-GH200, can process 1 trillion parameters in less than a second. It's like compressing the entire US Library of Congress into the blink of an eye. Opposite it, the Bitcoin blockchain network executes more than 200 quintillion calculation attempts per second to solve complex cryptographic operations. Yes, quintillions. A number so vast it far exceeds the stars in our galaxy. We're facing a clash of titans. On one side, NVIDIA, the undisputed queen of graphics cards, with chips capable of driving 70% of the world's artificial intelligence market. On the other, cryptocurrency mining, a decentralized digital swarm that consumes more electricity in a year than entire countries like Argentina or Sweden. What's impressive is how both worlds seek the same thing: to dominate compute time, the most valuable currency of the 21st century. To understand it, let's look at the real impact. Thanks to its GPUs, NVIDIA powers everything from the creation of hyper-realistic films to medical simulations capable of predicting virus mutations with pinpoint accuracy. Its chips are the invisible engine behind ChatGPT, Tesla's self-driving cars, and the most sophisticated defense systems on the planet. Meanwhile, the blockchain isn't far behind. Today, the annual volume of cryptocurrency transactions exceeds $11 trillion, equivalent to the combined GDP of France and the United Kingdom, and all thanks to a network that has no owner, never sleeps, and never shuts down. In energy terms, the comparison is brutal. A single NVIDIA data center can consume about 20 megawatts of power, enough to light up a small city. However, global Bitcoin mining absorbs around 150 terawatt-hours per year, the same electricity consumption as Malaysia, a country of 33 million people. We're in an unprecedented struggle. Two models that concentrate resources, innovation, and power. One is centralized and corporate, with a clear leader. The other is chaotic, distributed, and faceless. And the most fascinating part is that both paths cross. The same NVIDIA GPUs that train artificial intelligence are also bought by miners to extract cryptocurrencies. This is where competition becomes a paradox. The stage is set. The chip and blockchain war is not a metaphor. It's the real race to control the infrastructure of the future. Computational power is the new global currency, and whoever controls it controls the future. The battle between NVIDIA and the blockchain isn't measured in speeches, it's measured in astonishing numbers. To start, NVIDIA's latest flagship chip, the H100 Tensor Core GPU, achieves 60 teraflops of power in single precision calculations. What does this mean? It can perform 60 trillion operations per second. It's as if every person on Earth performed 7,500 mathematical calculations. At the same time, in parallel, the Ethereum network, even after its transition to a more efficient system, reached peaks of more than 1.3 million daily transactions. And that's equivalent to processing, every day, more operations than Visa's entire payment system did in its first 10 years of existence. Here's the key. NVIDIA concentrates its power in a few super data centers. The blockchain, however, disperses its capacity among millions of computers connected in every corner of the planet. It's centralization versus decentralization. Focused power versus distributed power. Now let's talk about money. NVIDIA's market value already exceeds $3.3 trillion, placing it among the most valuable companies in the world, surpassing historical giants like Apple or Saudi Aramco at certain times. On the other side, the total cryptocurrency market is around $2.2 trillion, which is equivalent to all the wealth produced by Italy in 1 year. The contrast is brutal, But both numbers prove the same thing. Computational power is now a more valuable resource than oil. Examples abound. With its chips, NVIDIA powers artificial intelligence training capable of generating images, music, and even molecules for new drugs. Each advance is equivalent to years of research compressed into weeks. For its part, the blockchain has allowed the creation of parallel financial systems, loans, contracts, and transfers that work without banks, borders, or interruptions. While a lab can use an NVIDIA supercomputer to decipher protein folding in a matter of hours, a cryptocurrency miner can, from their garage, be part of a network that validates billions of dollars in transactions every day. It's the democratization of power versus its strategic concentration. And here's the most revealing point. Both models need each other. Without GPUs, mining would have been much slower and less profitable. And without blockchain, graphics cards would never have reached prices as high as those seen in 2021, when a high-end chip cost more than a motorcycle. We're talking about a vicious cycle that feeds itself. Innovation drives speculation, and speculation funds more innovation. But the decisive factor isn't in the current numbers, but in where this power is growing. On the next page, we'll delve into the immediate future: planetary scale artificial intelligence and next-generation blockchains, which multiply the competition for resources and energy. The next frontier is not software or currencies. It's the planetary scale of computation. NVIDIA doesn't stop. Its stated goal is to build artificial intelligence infrastructures that function like global brains. The most ambitious project: super data centers that reach exaflops of power, that is, a trillion operations per second. For comparison, the human brain processes about 1 exaflop, but distributed among 86 billion neurons. NVIDIA wants to replicate that in silicon. On the other side, next-generation blockchains are advancing at a fierce pace. After transitioning to the proof-of-stake system, Ethereum reduced its energy consumption by more than 99.9%, yet still maintains a transaction volume that exceeds PayPal's. New networks like Solana or Avalanche process thousands of operations per second with minimal costs, approaching the speed of traditional financial systems, but without banks, permissions, or borders. The clash intensifies because both worlds compete for the same things: hardware, energy, and talent. The chips that NVIDIA manufactures to train models like GPT-4 or Gemini are the same ones many developers seek to build ultra-fast blockchain nodes. The result is brutal pressure on the supply chain. In 2023, a single H100 card reached prices of $40,000, the same as a new car. The magnitude is better understood with energy figures. If AI continues to grow at the current rate, by 2030, data centers could consume 8% of global electricity, a figure comparable to all of India's current generation. Meanwhile, if high-efficiency blockchains achieve mass adoption, we would be talking about tens of millions of daily users executing parallel operations, creating an unstoppable digital layer. Real examples already show this convergence. In Dubai, blockchain systems manage property registration with total transparency, while supercomputers with NVIDIA chips model urban climate to reduce heat by 2 degrees. On Wall Street, investment algorithms run on the latest generation of GPUs, while banks experiment with private blockchains to settle operations in seconds. The financial, scientific, and military worlds no longer distinguish between the two fields. They feed on both. AI needs security and traceability, which the blockchain offers. The blockchain needs efficiency and power, which the chips offer. We are facing a chessboard where it's not enough to gain more power. You have to integrate it, control it, and channel it. And this is where we reach the climax of this video. Now we will see how this technological war defines not only who dominates the present, but who designs the architecture of global power in the 21st century. Because we are no longer talking about simple calculations, but about geopolitical power. Every NVIDIA GPU manufactured in Taiwan is a strategic asset. So much so that the United States has imposed export restrictions to prevent China from accessing the most advanced chips. The competition is no longer between companies. It's between superpowers. Meanwhile, the blockchain advances like a ghost, impossible to contain. With more than 420 million cryptocurrency users worldwide, it represents a parallel system of trust that no government can shut down. Where NVIDIA concentrates power in factories and data centers, the blockchain distributes it among millions of scattered computers across all continents. The contrast is radical. Training a state-of-the-art artificial intelligence model requires more than 10,000 GPUs working together, with an energy cost that exceeds the annual consumption of 100,000 homes. In contrast, a single public blockchain like Bitcoin can mobilize more than $1 trillion a year in transfers without a central building or a supporting authority. The key question is no longer who has more power, but who manages to transform that power into real influence. NVIDIA turns calculations into intelligence. Faster medical diagnoses, safer self-driving cars, more intelligent defense systems. Blockchain turns calculations into trust, money without banks, contracts without notaries, identities without passports. Both models are irresistible. Both attract investment, talent, and state policies. And both inevitably collide. Because while chips set the pace for centralized innovation, blockchains propose a system without a center, without permission, and without hierarchies. And in that collision, what's at stake is not just who makes more money, but who designs the invisible structure that will govern our digital lives. What's extraordinary is that this war won't have a single winner. Technological history shows that revolutions don't eliminate their rivals. They absorb them, transform them, and force them to coexist. And all signs point to that being the case here. Artificial intelligence will need blockchains to ensure transparency in its decisions. Blockchains will need ultra-powerful chips to sustain the growth of millions of users. It's a rivalry, but also an inevitable alliance. In numbers, by 2030, the artificial intelligence economy is estimated to reach $15 trillion, while that of cryptocurrencies could exceed $7 trillion. Together, they would amount to the size of the two largest economies on the planet, the United States and China. So it's not about choosing a side. It's about understanding that the real battle is not just for control of computation, but for control of the future. A future where the chip and the blockchain are not enemies, but the two sides of humanity's most powerful currency, computational power.